Namaste children, I am Ramchandra Bhatt. Welcome to Samveda e-learning program. Already you are studying this chapter since previous 4 classes. This is the 5th session. In this session you are going to learn about important chapter carbon and its compound. This is the session number 5th. So that is the last session of the chapter. Let us recapitulate what you have learned in your previous classes. The combustion with or without flame, then oxidation, addition reactions, substitution reactions, then you have studied the properties of ethanol. What are the learning points of the session? The properties of ethanoic acid, that is the esterification reaction, then reactions of ethanoic acid with the base, then how ethanoic acid reacts with hydrogen carbonates and carbonates of metals, finally soaps and detergents. Now let us start today's class, that is properties of ethanoic acid. Ethanoic acid is an example for carboxylic acid as it is having what? This is having a COOH group. What is this? This is the carboxylic acid group. Now see, I will replace one hydrogen and I will attach COOH group. Then what happens? The methane is becoming a carboxylic acid, that is ethanoic acid. See here? Yes. This is the structure of ethanoic acid. You have to write the structure of ethanoic acid. Now let us see what are the important properties of this ethanoic acid. Ethanoic acid is a liquid at room temperature, that means its melting point is 290 Kelvin. It melts at 290 Kelvin. What is the room temperature? 298. That means at room temperature it is a liquid. Then what is the boiling point? It is 391 Kelvin. High melting point, higher than water. Then it freezes during the winter in the cold climates, hence it is called as glacial acetic acid. Here you are seeing the glacial acetic acid. Now it is used widely as preservative in pickles. Probably at your home you are using vinegar for many purposes. What is this? This is nothing but acetic acid, but it is diluted acetic acid. What are you seeing here? You are seeing many fruits and vegetables are kept in the acetic acid because it is a very good preservating agent. Ethanoic acid, when added to water, what happens? Just like any other acid, it undergoes ionization to produce H plus ions. Already you studied this one in chapter 2, acid, bases and salts, right? It is a weak acid, means it undergoes partial ionization. If you are having 100 molecules, all the 100 molecules are not getting ionized. They also have in molecular form as well as in ionic form. Here you are seeing, this is what? Ionization of acetic acid. Here you are seeing acetate, CH3COO minus plus H plus ion. All the organic acids are weak acids. 5 to 8% acetic acid is called vinegar. What is this? This is the vinegar. Now let us compare the pH of dilute acetic acid with hydrochloric acid. Let us use both litmus paper as well as pH paper or universal indicator. You can use either universal indicator or you can use pH paper or pH meter. Are both acids indicated by litmus test? Does the universal indicator or pH paper shows both the dilute acetic acid as well as dilute hydrochloric acid, both are equally strong? Which one is strong, which one is weak? Then let us perform very simple activity to understand this one. Dear students, what are you seeing? This is dilute hydrochloric acid HCl and vinegar. I am taking these two solutions in a small watch glass. What are these? These are the blue litmus paper. Let us immerse in HCl and vinegar. What is your observation? Yes, they turn into red indicates both are acids. Which one is stronger? Which one is weaker? Can you tell? No. For that one, here we have pH paper. Let me take the sample of HCl and vinegar in the watch glass. Now you are seeing the pH paper, 0 to 14 digits are there. I am plucking a paper from the set. See here, what is this? The beautiful red color indicates hydrochloric acid is very strong, while vinegar is, pH paper turned into orange indicates it is a weak acid. You saw the very interesting activity, that is the litmus test as well as pH paper test. What is the inference? Hydrochloric acid is a very strong acid because it turned pH paper into red, very dark red, while acetic acid shown orange color. You can remember Vibgyor, write Vibgyor in reverse order, then R indicates strongly acidic, blue violet indicates strongly basic, right? This is the simple mnemonics to remember the strength of an acid by using pH paper. Alright children, now esterification reaction. This is the very important and characteristic property of ethanoic acid as well as alcohol ethanol. Esters are most commonly formed when carboxylic acid reacts with an alcohol. This is the fruity smelled compound produced by the reaction between these two reactants. This is catalyzed by concentrated sulfuric acid. Ethanoic acid reacts with absolute ethanol in the presence of an acid catalyst, that is sulfuric acid. Then you are getting the product ester. Esters are formed, hence the reaction is termed as esterification. Now, how to do this one? Take 1 ml of ethanol, absolute alcohol in the test tube, and pure acetic acid is called as glacial acetic acid along with a few drops of concentrated sulfuric acid. Now warm the content on a water bath for about 5 minutes. Then pour into a beaker containing 20 to 50 ml of water. Now what is the smell? The smell is very fragrant, fruity smell. This indicates ester is formed. Now let us perform an activity. Here we are taking ethanol in the test tube. For this we are adding ethanoic acid, glacial acetic acid. Now let us acidify this one by adding catalyst concentrated sulfuric acid, a few drops. Now let us heat the content on a water bath for about 5 minutes. Now it is poured into a cold water. You will smell the smell of fruity substance. This indicates ester is formed. Now let us write the equations. With the help of animation, I will explain how the esters are formed. What is this? CH3COOH. This is the ethanoic acid. Now let us add ethanol, CH3CH2OH. This is the ethanol. Concentrated sulfuric acid is added and heated to 443 Kelvin. Now what happens? After some time the reaction completes and you are getting this ester. What is the formula of ester? CH3 COO C2H5. This is the ethyl ethanoate. Ethyl group is here C2H5, CH3COO part is ethanoate. So this is the ester. Then water is produced as a byproduct during the reaction. Then what is the role of sulfuric acid? Already known to you, this is an example for dehydrating agent, right? Generally esters are sweet smelling fragrant substances, hence they are used in what? They are used in perfumes, soaps, etc. They are also used as flavoring agents in condiments. Let us move on to next section, that is the saponification. Esters when react with the sodium hydroxide, they produce alcohol plus a sodium salt of carboxylic acid. You call this one as soap. That means chemically it is a sodium salt of carboxylic acid. Now this reaction is used in the manufacture of soap, hence the reaction is called as saponification. Here is the equation. When the ester CH3COO C2H5 treated with a base like NaOH or KOH, you are getting CH3COO or CH3COK potassium, potassium salt of carboxylic acid. Sodium acetate is the salt plus ethanol. Ethanol is produced back, hence we call this reaction is opposite of esterification, right? You are getting back ethanol. In the esterification, ethanol is consumed, right? Now this is the animation represents how saponification takes place. When ester is treated with sodium hydroxide, you are getting a salt. What is that? Sodium acetate CH3COONA. That is the salt of sodium. That is the soap, right? Now another byproduct is that is ethanol. This is the ethanol. Soaps are sodium or potassium salts of long chain carboxylic acids. Thus the reaction is called as saponification. Now let us see how the ethanoic acid reacts with a base. Like any other mineral acids, ethanoic acid also reacts with base like sodium hydroxide or potassium hydroxide to give a salt and water. Acid plus base is equal to salt and water, already you studied in the second chapter, right? You can recall that one. Now here is the equation. CH3COOH ethanoic acid plus sodium hydroxide produces CH3COONA sodium acetate or ethanoate, sodium acetate plus water. This is the reaction of acetic acid with a base. Here you are seeing exchange of sodium and hydrogen. The arrow mark indicates in the place of sodium, hydrogen comes. This is the double displacement, hence it is also an example for double displacement. Now reaction of carbonates and hydrogen carbonates with acetic acid. How they behave? Just like any other acid, you are seeing ethanoic acid also reacts with carbonates and hydrogen carbonates to give a salt, carbon dioxide and water. The salt produced is commonly known as sodium acetate. If it is potassium hydroxide, the salt would be potassium acetate. Now let us perform very simple activity related to this one. Now let us perform very simple activity to understand the chemical property of vinegar, how it behaves. Here you are seeing vinegar. Let us add sodium carbonate, or you can use sodium hydrogen carbonate also. Now let me add this compound to vinegar. What are you observing? Here you are seeing gas bubbles. This is the carbon dioxide. How to test this one? Let me add some more. What are you observing? The froth is coming out. Now let us pass this carbon dioxide through lime water. Observe the change in the color of lime water that turns milky, indicating the gas produced during the reaction is none other than carbon dioxide. Here you are seeing milky white. Now let us take some amount of ethanoic acid. Previously I did the experiment with sodium carbonate. Now let us take sodium hydrogen carbonate or baking soda. Let us pour some amount of baking soda into vinegar. Observe yes, you are seeing the froth. So this indicates evolution of carbon dioxide. How to confirm? Once again the same test. What you have to do? Pass the gas produced during the reaction through lime water, it turns milky, or you can bring a burning splinter or burning matchstick to the mouth of test tube which is extinguished. This is the equation of the experiment what we did now. When ethanoic acid reacts with sodium carbonate Na2CO3, it produces sodium ethanoate water plus carbon dioxide. Similarly, baking soda also produces same products. What's the difference? Difference lies only in balancing. Observe carefully. How will you test the gas produced during the reaction? Already you saw that one. What you have to do? You have to bring a burning splinter or burning matchstick to the mouth of test tube, it extinguished. Or you can pass the gas through lime water, then you will see turns milky, indicating the gas produced is nothing but carbon dioxide. How would you distinguish experimentally between an alcohol and carboxylic acid? It's very simple. Already you studied properties of ethanol as well as ethanoic acid. Compare. Ethanol does not react with these two reagents. That means you can easily identify, right? Then reaction of these two compounds with the base NaOH also different. Reaction with sodium also different. One is sodium ethoxide and one is sodium acetate. By these two you will easily distinguish both the chemicals. Now let us move on to very important compounds which are used in our daily life. They are soaps and detergents. So you are using these things, these are part and parcel of our life, right? So we should know what are these. What is this zigzag line? This zigzag line indicates hydrocarbon part. The red colored CO minus Na plus indicates that is the ionic part, very important part of soap. How the soap cleans? This is zigzag line is called as hydrophobic part, means phobia, fear, means don't like water. It is the hydrocarbon end. And this one is ionic end, attracted by the water, hence it is called as hydrophilic, water loving end. This is the ionic part. The soaps are chemically sodium or potassium salts of long chain carboxylic acids. Already in the saponification you learned this one. What happens when soap is added to water? Inside the water these molecules have unique orientation or alignment that keeps the hydrocarbon portion out of the water. you will see the yoga done by these soap molecules. This is how the Shirshasana performed by these soap molecules. Very interesting, right? Now let us see how the soap act on the dirt, that is the action of soap. Oily dirt does not dissolve in water. The ionic end of soap interact with the water while the hydrocarbon chain interact with the oil. The soap molecules thus form structures called micelles, what you are seeing here. This is the arrangement of soap molecules around the dirt. Now let us see cleansing action of soap with some more animation. What is this? When the dirt is there, it attracts the hydrocarbon part, like dissolves like. Hydrocarbon part, organic part. Similarly, dirt, oil, also organic. Water is a polar solvent, we say, so ionic part is attracted by the water. Thus they are forming intermediate structures called micelles. Now these micelles pull off the dirt when you wash the cloth. This is how the cleansing action of the soap is represented here. Hydrocarbon end of the molecule is towards the dirt or oil droplet, while ionic end is facing towards the water, that is outside, right? This forms an emulsion in the water. Now the soap micelle thus helps in pulling out the dirt in the water when you wash the cloth. This is how you are cleaning the cloths. Now one more question. Why the soap solution turns cloudy? Why this looks like cloudy? What is the reason? The secret is, already you studied in 9th standard, that's a colloid. Micelles stay in the solution as a colloid and will not come together to precipitate because ion-ion repulsion. Because of this, there is a repulsive interaction. The dirt suspended in the micelles is also easily rinsed away. The soap micelles are large enough to scatter the light, hence the soap solution appears cloudy. This is the secret of cloudy appearance of soap solution, right? Now, what are the disadvantages of soaps? Soaps are not good in hard water. They form scum. When you bathe in such water, some scum will be found attached to your skin. Soap reacts with the calcium and magnesium salts present in the hard water to produce the scum. These salts cause the hardness of the water. These salts are responsible for hardness of water. Hence we need to use larger amount of soap. This wastes the soap. This is the problem with the soap in hard water can be solved by using another class of compounds called detergents. These are better than soaps in hard water. Hydrogen carbonates, chlorides and sulfates of magnesium and calcium are responsible for hardness of water. Now, you are seeing here the detergents just now I mentioned. These detergents are generally sodium salts of sulfonic acids or ammonium salts with the chlorides or bromides as ions. Both have long hydrocarbon chain, soap, hence these are called as soapless soaps. Now, the charged end of these compounds do not form insoluble precipitates with the calcium and magnesium ions in hard water, hence there is no scum formed. So it cleans quickly. These are the surface reactive substances. Thus they remain effective in hard water also. Detergents are usually used to make shampoos, remember this one, and products for cleaning the cloths. Now we came to end of this class. That is now what you have learned. Let us recapitulate what we learned till now. that is the properties of ethanoic acid, both physical and chemical properties, esterification reaction under chemical properties, reaction of ethanoic acid with a base, and then reaction with carbonates, hydrogen carbonates, then finally soaps and detergents. These are the important concepts covered in this session. This is the quiz time. Let us test what we learned till now. Are you ready? The quiz time starts now with this question. The melting point of the glacial acetic acid. What is the melting point? 290 Kelvin, 300 Kelvin, 353, then 391 Kelvin. What's the answer? The answer is right, 290 Kelvin. Now the next question. Ester among the following is, identify the ester. CH3COO C2H5. Next option is CH3CONA, CH3CO C2H5, and the last option is CH3CH2O C2H5. What is your answer? The answer is yes. This is the first option, CH3COO C2H5, that is ethyl ethanoate. That's the ester. Now the next question. Soaps are produced when ester reacts with ethanol, ethanoic acid, sodium carbonate, and sodium hydroxide. What is your answer? The answer is, already you know, saponification reaction, that is the sodium hydroxide. The next question is, soaps added to distilled water, then which picture represents the process correctly? Identify. Here is the first picture, this is the second one, the next one is C, this is the D. What is your answer? Are you ready? Yes. This is the answer, already I told, this is how the Shirshasana done by the soap molecules in water, right? Next one. Carbon dioxide is evolved during the reaction between ethanol and ethanoic acid, methanol and baking soda, sodium carbonate and ethanol, lastly vinegar and sodium carbonate. What is the answer? The answer is vinegar and sodium carbonate. Now we came to last section, that is the homework section. The first question, explain the cleansing action of the soap. You have to explain with the diagram, right? Now what is the use of concentrated sulfuric acid in the esterification? Now the next question, how will you chemically distinguish ethanoic acid from ethanol? This also known to you, very simple question. Now saponification is opposite of esterification. Next one is, what is the use of esterification reaction? The last question, write the chemical properties of acetic acid with the chemical equations. Dear students, till now we discussed many points on the chemical properties of ethanoic acid. I hope you understood these things. Also I explained the activities and did many experiments. You enjoyed those. Not only enjoying, you learnt many things. This prepared yourself for the examination. Now you are able to answer to higher order thinking questions also. I hope entire 5 sessions helped you to prepare for the exam. So I wish all the best for your exam. Namaste. Bye bye.